Privilege escalation is a bug class that comes in a lot of variations, and to know best what we should focus on, I did the case study of 162 public bug bounty reports, and in this video I will show you which ones get the highest bounties. Enjoy! So I have 9 different groups of what the attacker was able to do with the attack, and we'll go through them one by one, starting with the most common one, which was reading victims' data. It was the bug class that is kind of overlaps with IDORs, but because I already have done the IDOR case study, I tried to focus on a bit different things in this case study. As the example, I have this report by Yusuf Samuda from Facebook, where there was a free request process to upload the file, and these are always interesting because when you have your data in the system, it's stored in some kind of database where it's tied to your user ID, and it's still possible to make a mistake and have the IDOR there, but it's way harder to do something secure with files because files, they don't have metadata. Files only have the file name and the file content, and that's usually it. So any request that handles files is interesting, especially like here we had one request where the user would upload the file to a CDN, then in the response they would get the video ID, then in the second request they would exchange the video ID for some other identifier that looked like this, and then there is the third request which connects the uploaded file, uploaded video with the user's profile. And in these types of requests, of course, in the first one, you should always try different things with the file path traversals and stuff like this. But this second and third one here, always try to see if you can access other users' file ID, especially if it's a predictable one. And in this case, the second request was probably secure because it's not mentioned in the blog post, but in the third one, Yusuf could just exchange the video ID for another user's ID, and then other file would be appended to normal user's profile, would be normally shown on the user's profile. In this case, I think Yusuf appended some kind of internal crash log screenshot, and he was rewarded $12,500 bounty by Facebook. Now, some of these reports will be similar to IDORs, but because I think every single IDOR is a kind of privilege escalation bug, I did not want to include them again because I already did the IDOR case study. So keep this in mind when looking at these statistics. The next group that we have is creating or modifying resources with only one less report, but a lot higher bounty, which is kind of interesting because it is not due to the fact that creating or modifying resources is by CVSS more impactful, because if we take a look at CVSS, this is the typical setting that you would use for any kind of IDOR. So this would be for creating or modifying resources, and this would be for reading, and both have the rating of 7.5. So CVSS-wise, there is no difference in the impact between these two groups, but in practice, we can see that there's a clear difference in the average bounty. Maybe it's because of the fact that if you can modify or create resources, likely you can at least partially read something, so then the impact increases. But one way or another, it's always worth to look for the bugs in all the possible actions of creating and reading as well. And I have this report by Teddy Katz as the great example. This one was in GitHub, and systems that maintain version control are especially interesting because of how commits work. I won't go into the detail of how this particular report worked. The TLDR is that Teddy could add himself as the maintainer to somebody else's repository. But the thing I want to mention about these systems is when you have a target that works with files from one particular repository, from one particular organization, It may seem that it is secure because they will not pull files from your repository. But if you control the commit hash, know that if you fork the repository and create a commit on your fork and never merge this fork, never make a pull request, the commit will be available on the main repository using the same hash. That's how Git works, and this is the feature, not the bug. And developers that create some apps forget about this, and they do not know that if you control the commit hash, you kind of control the whole repository, because you can then just pull your own fork with whatever you want inside. So keep this in mind when testing for anything that works with Git when you control the commit hash. Then the next group is permanently escalate permissions within the organizations. So these are the attacks where the attacker is somebody that's inside the organization, but they have low privileges. And by executing the attack, they can escalate their privileges to admin, to manager, whatever the role is. And these attacks are that much impactful that the two previous groups, they were only working for one particular request. You could read one thing or modify one thing. And if you elevate your permissions, from now on, you have elevated permissions and you can do anything that the admin can do. So most of the time, if we take a look at CVSS, most of the time you will be confidentiality and integrity high, but because you have to be part of the organizations, you will have privileges required low, or in some cases even high. It is very dependent. If you can escalate from, let's say, admin to owner, that's privileges required high. But one way or another, these attacks are definitely great. And we have 30 reports, so this is a common problem. And most of these were happening inside the functionality of organization or user management. So these are quite, it's good to test for them because you just have these functionalities that you have to audit. It's not like you have to see every single request. And before somebody asks in the comments, you can access this database in the BBR Premium archive that's linked in the description. The example I have is very, very simple attack in Facebook. You just have this request and analyst can elevate their permissions to admin. You just use your own user ID, ad account ID, permission ID, and that's it. And a lot of privilege escalations look simple, but the real value that the hunter did was just browsing the app, auditing a lot of endpoints, seeing which ones are secure, and then all of a sudden finding the vulnerable one. And then the report is often as simple as this one, but yeah, the real value is outside of this write-up. So don't be fooled that it's so easy to look for privilege escalations. The next group that we have is deleting resources, which sort of completes our 4 actions that you can do with the object: create, read, update, delete. And there are fewer reports than the 2 previous groups, but I still think you should spend a lot of time testing for deleting resources. The first reason is it is less obvious. As the less experienced version of me, I used to kind of ignore the delete actions because I thought there is very little impact. If we take a look at CVSS again, keep in mind that if you can delete a resource, that's not an availability impact. Availability refers to availability of the system and not availability of the data, which means even if you can delete all the data in the system, availability impact is none. Deleting data is integrity impact. So CVSS-wise, you're in the same sort of bracket as updating or creating resources. Of course, if what you can delete is not very sensitive, it may be integrity low, or it might even be a non-qualifying vulnerability. But in other systems, it will be maybe even more dangerous than other actions. And one other aspect why I think this deleting is, you're more likely to find it, especially in hardened targets, is because it's harder to test for. Because if you have the read action, it's fairly easy to automate this. You can do it with authorize. You can write your own script that just has the IDs of different objects, you just send the request from a different session, and that's pretty much the check done. When you have updating or creating, it's a bit harder because you need the proper body of the request. And even if you can automate some fetching from JavaScript or by whatever other means, you can enumerate names of the parameters. Likely you will still not know what are the values of those parameters. So it's harder to automate this. And deleting, I would say, is even a little bit harder because if you send a request from the original session, you cannot replay this request from the attacker session because the object is already deleted. So you need to find another one. And these things, even though if you're just testing, one resource, it's not a problem to do this. But if you think about, multiplying this process times 300 endpoints, 400 endpoints, 1000 endpoints, that's a lot. So that's why there's definitely more privilege escalation bugs and iders in those actions that modify something than in the read. And especially if you have GraphQL, it is possible that you can not only delete the data, but also read it at the same time. In this example, you could just delete it, but when you have a GraphQL mutation that looks like this, here you ask the system about what it should return in the response after deleting the object. And here it's just error, so this is only deleting the resource. But in some cases, you will also be able to see the contents of the object that you just deleted. So then you have both the confidentiality and integrity impacts. So yeah, when you have GraphQL, always pay even more attention than normally to deleting objects, even if they may not be sensitive to delete. If you're able to read them, that's definitely sensitive. So pay attention to this. The next group is something interesting because I've never actually tested for this. At least I haven't spent a lot of time testing for this. It's when the attacker keeps their old privileges. So the attack scenario is that the attacker already has some privileges in the application, but it's impossible for the legitimate user to remove the attacker from the organization or remove attacker's permissions. So sometimes it's as simple as just the session token not being invalidated for a long time, where the attacker can refresh it over and over again. But we also have a very interesting report here in Reddit, where the Hunter 41bin found something that seems like not something severe. They found a way to create the user that would be hidden from the user list. And probably it's something that I wouldn't even report. I would probably brush it off as maybe a low-risk vulnerability that the company will not reward, or at least not reward well. But the attack scenario that the Hunter came up with is to, as the attacker that already is the admin in the organization, create another admin in the same organization, but the one that's hidden. So then, when, let's say in the real world, the attacker leaves the company, and the company, the user with the owner permission wants to remove them from the organization on Reddit or on Reddit ads in this case, they remove the attacker, but because the hidden user created by the attacker is not visible to the owner, the hidden user is not deleted. And of course, the attacker has credentials to this account, so they can keep those permissions forever. And it's also kudos to Reddit here, because they rewarded it at $5,000 as a high. And I want to appreciate it because I feel that sometimes, even though we say in bug bounty impact is the king, I still feel that often it's hard to get paid well for something that's not a standard vulnerability when you do something that's out of the box, or something that doesn't have a bug class name or something like this. It's harder to get this through triage, and it's harder to get this paid well, even if the impact is there, just because it's non-standard. But it's not the case here. Here, Reddit took a look at it at the impact standpoint, not at the backlash standpoint, and they rewarded it fairly. So well done, Reddit. Then joining another organization, and you can see that there is way fewer reports of this type, 9 versus 30 of escalating privileges within the organization. So even though joining another organization is more risky, and you can even see the average bounty is way higher than other bug classes here, even though it's a small sample size, it's the best we can get, but take it with a grain of salt. But you can see that it is not as easy to perform an attack that allows you to join another organization. Now, why is the average bounty so high? That's probably because there are 4 Shopify reports rewarded in total over 65K, and also $35,000 of Facebook reports. And the ones in Shopify, there are a few reports by Ron Chan that are kind of related. I covered them on my channel. You can see them. The link is in the description. Just if you watch it, remember that it's one of the first videos on my channel, so you will see how much the quality of the videos have improved. But I still recommend you to watch it because this chain is incredible. It's a race condition where with the email confirmation process, where Ron was able to confirm another email by changing it at the correct time, and specifically in Shopify, bypassing email confirmation allowed you to take over the whole shop. So it is a big thing, and I think 3 of these reports in total that I covered were rewarded $37,000. So yeah, it's definitely something to pay attention to. Next, we have Paywall bypasses, and it's a bug class that I was very curious about because it's not something that I test a lot, and I wanted to see if I should. And to be honest, if anything, this case study convinced me that I shouldn't spend a lot of time here. We have only 7 reports in this group, and they are not really rewarded that well. We can see 2 reports rewarded $2,000 from Shopify, which doesn't sound bad, but it's still rewarded as a low. And I imagine a lot of companies just didn't accept them at all. So yeah, to sum it up, it's not something that I'm going to be spending my time on. Then the next group that's kind of named a bit strangely, bypassing victims confirmation. It's the attacks where I wasn't really able to determine the immediate impact. An example we have here in Slack, where if you invite somebody to the Slack workspace, they have to accept the invitation, and you could bypass this accepting the invitation. So you could invite the victim to the workspace and have them automatically accept the invitation by, I think, changing their role immediately. So there's no immediate impact to this because it's the victim joining your Slack workspace. But because there is the confirmation, it is there for some reason. So some companies will pay for this if you can bypass that. It's probably not something I'm going to spend a lot of time on as well, but it's something to be aware of, that if there is a confirmation, it might be there for a reason, and in some cases, we might not even understand the business impact and the real implications. So yeah, keep this in mind. And finally, the last group, which for me is a very important one because it's not something that I used to test for, and I probably will start from now on. OAuth app that has too many privileges. And if you know me, you know that I love OAuth. It's probably the first functionality that I test on every target. But these scenarios, it's not something that I really considered. So what happens here is when you log into example.com with your Twitter account in this example, you are being shown this consent screen. And when you authorize the app, what happens on the backend? The app, the example.com, gets the access token with which it can communicate with the Twitter API and fetch some information about you, modify some information on your behalf, and do other actions. And exact actions are being shown on this consent screen. So here it clearly says what the application can and cannot do. And The attack scenario here is that this access token that the application has actually can do the actions that this screen says it mustn't. So the access token allowed the app to access person's direct messages, while the permission for this was not given on the consent screen. And Twitter rewarded this $3,000, almost $3,000. And it's interesting for me because it's kind of hard to test because you have to create your own application, which also means you're limited to targets that allow to do this. So it's like Facebook, Twitter, Google, and other big applications that allow to use themselves as authorization server to log into other websites. And the attack scenario is that you have to create the app and go through the flow and fetch the token, and a lot of people just won't do it. So they won't test for this scenario. And this is one case that can happen, that the token has too many privileges compared to what was shown on the consent screen. But it gets even better here. We have a GitHub report from Tanner, which was even better because the application to which you granted permissions had more permissions than the user giving the permission. So the attack scenario changes here significantly because now the user can just create their own application in the organization, and all of a sudden this user's application has more permissions than the user themselves. So it's a normal privilege escalation inside the organization. And that's why this scenario is more dangerous, because at the end of the day, the user can just escalate their privileges, but the sort of way to do it is very creative, and it's probably not something that a lot of people test for. And in this case, it was rewarded $10,000. So a really, really nice attack, and definitely something for me to add to my testing methodology. And that's it. These are all the groups that I have prepared for you today. If you want to see the full case study, it's available in the BBR Premium Archive. And if you enjoyed listening about privilege escalations, check out this episode of the podcast that I recorded with Douglas Day, who's the absolute best hunter when it comes to looking for privilege escalations. The link is on the screen right now and in the description. And for now, thank you so much for watching, and goodbye.